Okay, so this is the Coolapet robot for WES 237A. My name is Aaron Coffman.
And I'm Charlie Hall. Brief background and introduction to our project. Our final project for WES 237 is a mobile cooling fan for pets. We called it the Coolapet robot. The system entailed addition of hardware as well as modification to the hardware configurations for the previous homework assignments. The mobile cooling robot utilizes data gathered from remote waypoints strategically placed in the environment, i.e. close to the pet beds in the home. The waypoints consist of an embed microcontroller collecting data from a temperature sensor as well as from two beam motion sensors. This data will then be relayed wirelessly using XB transceivers when queried by the robot. There's an additional XB on the cooling robot that will receive the data and take action. Our application utilizes a priority handler to make decisions based on relayed data. The most frequently used bed set as the highest priority. The robot will then proceed to cool the prioritized location in the environment, leveraging predetermined routes. Our application then decides to cool a specific location based on temperature and motion sensing. If the temperature does not meet the minimum threshold, the application moves on to the next waypoint. If the temperature threshold is met, the application will then use the beam motion sensor data to decide if a pet is there to cool. If there is movement, the location is a candidate for cooling, and the predetermined routes are pre-programmed based on the environment the cooling robot is to operate in.
The hardware components utilized for the Coolapet robot system are as follows. 1 5-volt powered fan, 2 temperature sensors, 4 passive IR motion sensors, 3 DC to DC converters, 2 LP1768 embed microcontrollers, 1 iRobot, 1 Raspberry Pi 3B, 3 XB wireless transceivers, 4 lithium-ion batteries, and 1 5-volt relay.
Alright, in this video we are going to decompose the iRobot as well as the waystation for our Coolapet robot system.
Okay, so on the left here we have the iRobot itself, which has its own internal power. On the back side here we have 2 separate power sources. We have a lithium polymer battery on the left here and a lithium ion battery in the back. Up here at the top, if you look through, you can see the Raspberry Pi here. You can see that we have a DC-DC converter in there, a relay which is controlling this brushless fan up here, and then we have an XB transceiver mounted in the front here. Over here on the right, we have the waystation. So the waystation is comprised of a lithium polymer battery, a DC-DC converter, an XB transceiver, a temperature detection unit, and 2 motion sensors.
These motion sensors are mounted in what we're calling directional tubes. It's basically toilet paper with electrical tape on the outside. We found these sensors to be extremely sensitive, so we needed to have them concentrate on a smaller area. We were getting pickup of hand motion from 15 feet across the room, and for this to work for the bed, we needed it to be a little bit more localized.
The waypoint also is comprised of a embed microcontroller. Okay, so we're going to demonstrate the hardware functionality of the Coolapet robot. We have the robot here on the left, along with Waystation A and Waystation B. We have disabled the drive command so the robot does not drive off the table, and we have set our temperature threshold to 10 degrees Celsius. So we're going to go ahead and start the software routine here. The basic functionality of the software routine is there's a periodic cycle. At the end of every cycle, the robot will query each waypoint, asking it for its temperature and motion data. So we can see here the robot is now querying each waypoint. We do not receive any motion detection. We have the temperature printed for each waypoint, and then every 10 seconds the robot is going to requery the waypoints to check the temperature and motion data again. So the basic routine is query waypoint A, ask for temperature. If temperature exceeds a set threshold, which at this point is set to 10 degrees C, The robot will then query the same waypoint again, asking for its motion data. Once it queries waypoint A, it will move on to waypoint B, repeat the same process where it asks for temperature detection first, and then motion detection if the temperature threshold is exceeded. So at this point, we're going to go ahead and demonstrate the functionality of the motion detection as well as temperature detection and fan control.
As we alluded to earlier, we are using our fancy toilet paper rolls here to concentrate our motion detection. First, we're going to demonstrate one of the motion sensors being set off and the fan actually not going off. And then we're going to do both so that the fan will go off. So this is setting off, hopefully, just one of the motion sensors. And you can see that our program here is going to say that there is no motion detection because not both of them were met. So now I'm going to try and get both of them with a more wide sweep. Hopefully the program here will say waypoint A, motion detected, as it did. It's going to go into its drive routine, turn on the fan for, I believe, 20 seconds.
Yeah, it's set to 10 seconds right now.
10 seconds. This would be the point where we would probably configure it for more in a real-world situation to actually bring the temperature down of the dog. Now it will be driving home after it went to the bed. That is the second drive command. And then it should restart. As you can see, it pinged waypoint A and B. No detection. So I'm going to set off both this time. And again, I'm going to take a rather wide sweep here to get both of them to go. The next print, we see motion detection on A and on B. First drive command is from home to bed A, and we set that priority based on the preferred bed of the pet. After the fan duration is over, it will drive from bed A to bed B. It will do the fan cooling again. Once that is complete, it will go from bed B to home, which is the third drive command. And then after that, we should be in the loop again, where we are now querying the waypoints for more data. And hopefully, if we were still enough, neither of the motion detections were set off. And it looks like neither of them were.
So the premise behind this dual beam setup here with these waypoints is that we realized that when we only had one motion sensor, there was a case for erroneous motion detection. So while utilizing two beams, we're able to cross them, and if the pet is at the focal point of the two beams, this will give us a positive detection of an animal. Okay, this is a demonstration video for our final project, the Cool a Pet robot. As soon as I press enter here, our application will begin. Right now we've got the temperature sensor threshold set to 10 degrees Celsius, so that will always trigger. And then we'll be manually setting off the beam motion sensors that we have on our waypoints in order to trigger the motion. From that point, we're going to show some of our predetermined routes. We go from pet bed A, which currently has the pet on it, and pet bed B, which is over in the corner. Pet bed A is his favorite bed, so we have deemed that the priority bed. And if both of the motion sensors and the temperature is met for both beds, it will go to A first, and then it will go to B. If it does not sense motion and temperature on either bed, then it will not go. If it senses it on one, it will just go to one and then go home. So right now I'm going to come back to the console and start our application. First thing is from the iCreate platform, just telling us the battery level of the Roomba. Period is set to 10 seconds right now for the waypoints to ping. As you can see, we've got temperature sensing, and both waypoint A and B are set to 0, which means we did not get any sensing. Aaron has just set off the sensor on A, and hopefully on B. I missed B.
Oh, we missed B, so it looks like we're going to do pet bed A first, and then home. As you can see, as soon as the Roomba gets to the bed, the fan has turned on to cool the pet. Right now we have the fan interval set for 20 seconds just for demonstration purposes. And as you can see, Our Roomba is now returning back to what we call home. Now we are going to demonstrate going from pet bed A to pet bed B. And you'll see Aaron sprinting to the next waypoint there to set off both of them. Looks as though we have gotten both to receive. Yep, you can see waypoint A, waypoint B, both won. This is the same operation you just saw from home to A. The fan turns on, runs for 20 seconds. And then from this point, we're going to go from this pet bed to the second one, based on the priority, since they were both triggered. And on this long ride, we may have to help coax it, because we have had some issues getting our robot to drive straight, which should be no surprise. So as you can see, the robot is now going to the second bed. Turns on the fan again for 20 seconds. After the operation is complete, it will then again turn and return home and continue to listen for motion and temperature sensing from each waypoint. Again, these waypoints are next to the bed, and right now we have set the temperature threshold to be 10 degrees for demonstration purposes, and we are continuing to correct the Roomba because we have had issues getting it to drive straight. But with a little help, it can go back home. Alright, this is going to be our demonstration of home to pet bed B. Right now, we are going to try and trigger pet bed B only. Looks as though that was successful. We're going to do a route from home to B, and I'm going to correct it a little bit as it rolls to make sure that it gets there. As you can see, we're getting a little bit of left drift. We've got to correct a little bit to the right so it can get to the bed. It gets the spot it needs to, rotates, and starts the fan. After 20 seconds, it will again turn and return home. With a little bit of coaxing, this guy might actually make it through the corridor that we have made here. Ah, there we go. Perfect. Just a little tap. And then again, it returns to almost home.
Okay, so we're going to demonstrate a practical real-world implementation of the Coolipet robot, which you can see across the room there. So we have set the temperature threshold to 22 degrees Celsius, which is approximately room temperature. So we have the door over here open, and we have way station B next to the door, and you can see in the dog bed B we have the temperature sensor embedded. You can see the LED light on there. So we're hoping temperature over here will be cooler than room temp. Over here in bed A, we can see that we have an animal present. There is a temperature sensor embedded in that as well. Actually, it seems that we have detected movement and an elevated temperature already.
So yes, I was going to say that these are not perfectly aligned to catch his movement, but it seems as though it has this time. The bed has moved from home the robot has moved from home to the bed and started its cooling process. Now we'll be going from the bed back to home. It has turned off the fan and returned home. We can do it one more time.
So at this point, the robot would be querying both way stations again. First A, checking for temperature and motion detection, and then again B, checking for temperature and motion detection. We should get no motion detection at B. Let's see what happens at A. So the dog has...
as you can see, these aren't perfectly optimized for this situation. We've mounted these on a box just so that we could get semi-directional. I'm gonna, kind of poke him here with the bear claw and see if I can get him to move a little bit. That should have done it. That should be enough movement to set it off, but we shall see.
So again, the period set to 10-second detections.
Alright, so I just saw the LEDs flash on the embed, so it looks like both sensors were met. We're going to do the same routine that you just saw. It's going to drive right to the bed. It's going to get there, stop, do its cooling routine. Right now, for demonstration purposes, it's set to a relatively low duration. I believe it's still 10 seconds. Again, once it's done with its cooling routine, it will turn off the fan and then return home. If we had another pet in the scenario and the temperature sensor was met and motion sensor was met in pet B, or in the second bed, it would go from bed A to bed B and then return home and start its routine again.